Good afternoon, everyone, and welcome to Parsons Technical Webinar Series. I'm your host, Jessica Bennett. We're very excited for today's webinar that will be presented by Karen Levin and Eric Dominga on acid rock drainage diversion case study and environmental water quality success story. Next slide, please. Few quick housekeeping items. We'll be keeping all phone lines muted to limit background noise during the presentation until the Q&A at the end. If you have any questions throughout the presentation, you can either enter them into the chat or you can raise your hand and ask them at the end during the Q&A session. This webinar has been approved for 1 PDH credit. If you'd like to receive a certificate for a PDH, there's a link to the attendance form that will be posted in the chat. There are 4 multiple choice questions in that attendance form that you would need to answer. And I will also post those questions in case you can't reach the form during the presentation. If you have any issues downloading that form, you can let myself know or danielle.savin@parsons.com and we'll get you that form. And finally, this webinar is being recorded and will be posted on our YouTube channel in the next coming days. Brief agenda will introduce the guest speakers today and then present a core value moment, followed by the technical presentation and then a Q&A session at the end. Next slide, please. Karen Levin is the Deputy Project Director for the Faro Mine Remediation Project in Canada. She's been working in the mining industry for over 20 years, mainly in remote northern Canada and Arctic locations. Her experience has included all phases of mining, from construction and operations to closure and remediation. She has a bachelor's in environmental science and is a certified environmental professional and also a lead ISO auditor. Eric is the Director of Construction Management at the Faro Mine Project with 27 years of experience with large environmental remediation and heavy civil construction projects. He's been involved in the Faro project since 2013. And with that, I'll turn it over to Karen for the core value moment.
Thank you for the introduction and opportunity to speak today. We chose sustainability for our core value moment. Sustainability really encompasses everything that the long-term Faro Mine Remediation Project hopes to accomplish by returning the land back as close as possible to its original state. All of these pictures are taken at the Faro Mine Complex. The project is located in Canada's vast boreal forest, which provides refuge to endangered species such as boreal caribou, grizzly bears, and wolverines. It is extremely biodiverse and supports many fish species and a variety of wildlife. The boreal forest plays a critical role in protecting our climate from carbon emissions. The entire Canadian boreal forest contains over 300 billion tons of carbon and is essentially that's as much carbon as the world emits over 36 years. The boreal plays a critical role in regulating our Earth's climate. The central picture is of Kaska community members and Parsons representatives at the ribbon cutting ceremony the day the North Fork Clean Water Diversion Channel was commissioned. It was a very important day for the Kaska people as it signified a step towards the long-term remediation of the Faro Mine. The Faro Mine is located in Kaska traditional territory and is in a culturally significant area for their people. Although the project remediation focus is driven through a construction lens, it is ultimately about environmental stewardship and community sustainability. I wanted to share with you the following statement from the Ross River Denna website. The Ross River Denna are the closest Kaska community to the Faro Mine. The webpage is titled, "Who are the Ross River Denna?" Welcome to our land. For thousands of years, our ancestors have cared for this land, and today we are the people that have inherited that important responsibility. We have learned from our elders that those that have come before us, that if we take care of the land will take care of us. This land is our home, our sustenance, and our culture. The Faro Mine is located in the northwestern corner of Canada, and people listening from the US today is outside Alaska. Faro is located just below the Arctic Circle, which is 60 degrees north of the Earth's equator and is just below 60 degrees of the Earth's equator and is considered subarctic, so we're not above tree line at this point at our location. The project is in a remote northern location where the summer days can be up to 20 hours long and During the winter, there is limited daylight between only 2 to 4 hours. The summer temperatures can reach up to 30 degrees Celsius, and the winter low with a wind chill can dip down to minus 50 degrees or lower. The geographical map on the left is of the Yukon, and the red star represents, there's no red star, but I will use my pointer. I guess I am still having some difficulties here. So right here we have Whitehorse, which has the largest population of people in the Yukon. The blue up here at Faro, which is a 4-hour drive northeast of Whitehorse. And this is the area that the Faro mine is located. The Faro mine is approximately 22 kilometers from the town of Faro and is on the asserted territory of the Kaska Nation and upstream of the Selkirk First Nation. The map on the right is of Kaska traditional territories. The red dotted line is the Kaska territory boundary, and the Kaska people are joined by 10 Kaska communities, which form the Kaska Dena Council. The Faro mine operated for 30 years between 1969 and 1998. It was one of the largest lead and zinc producers on the global market during that time. The Faro mine complex is approximately 25 square kilometers or 10 square miles. In 1998, the owner declared bankruptcy and the Faro mine was abandoned. In 2003, the Faro mine was identified as a shared responsibility between the government of the Yukon and the government of Canada. In 2018, the government of Canada took sole responsibility for the care and maintenance of the site. Between 2016 through March 2022, Parsons was the care and maintenance operator at the Faro mine. Recently, Parsons won the main construction manager MCM contract for the long-term remediation of the Faro mine, with contracts starting April 1st of this year. The mine was constructed using historical mining practices and left behind some legacy mine infrastructure, such as a large tailings facility, waste rock piles, and open pits and dams. There's approximately 70 million tons of tailings on the site, 320 million tons of waste rock. The Faro mine remediation project is considered one of the most complex abandoned mine cleanup projects in Canada. The long-term remediation is expected to take approximately 21 years to complete. The Faro mine is located in a significant cultural area for the Kaska, known as Tezoul. The Tezoul site at Faro was and still is a significant area for the Kaska people. It was a place where the Kaska gathered in the summer and fall to hunt, having an abundance of wildlife. They were able to live from this land for thousands of years and will continue to utilize this land long after the remediation has taken place. The Kaska traditional lifestyle includes hunting, fishing, and berry picking. The remediation of the mine is a top priority for the Kaska. The North Fork Rose Creek diversion was initially a part of the longer-term remediation phase of the project. However, it was completed as an urgent work package under the care and maintenance contract due to degrading water quality and to protect the downstream environment. In 2013, routine water quality monitoring identified an upward trend in the zinc concentrations at the final compliance station on Rose Creek as the water leaves the mine area and heads into the downstream environment. In 2015, a seepage collection system was installed as an interim measure in the North Fork to collect and reduce zinc concentrations. The North Fork diversion channel designs were expedited and completed, and in 2018, the construction of the diversion channel commenced. And on October 24th, 2020, the construction was completed and the NFRC was commissioned, resulting in an immediate reduction of zinc concentrations at the North Fork compliance point and the downstream Rose Creek compliance point. The project is currently undergoing an environmental assessment review and is expected to receive an EA certificate between 2024 and and 2026. And having some technical issues here again. Along with the new EA will be a new water license. The Effluent Quality Standards, or EQS, in the table are the regulatory criteria we are currently required to meet in order to be compliant at our receiving water location. The parameters highlighted in red, apologies, it's not showing the correct slide here. However, it is the zinc at 0.5 milligrams per liter, the total suspended solids at the top at 15 milligrams per liter, the turbidity, 15 NTUs, color, and the pH. Which are the main parameters of concern in the North Fork area, and were the ones that drove any non-compliance prior to the construction of the North Fork of Rose Creek. In combination with meeting the EQS, we use an adaptive management approach, which means we can be more flexible. The Faro mine is complex, and experience has shown us that it's impossible to foresee all situations that may arise. By monitoring the site, we can watch contaminant levels and take early action if we anticipate that unacceptable levels of contaminants may enter the downstream environment. These are called AMP triggers and work in a gated approach. Green is no effect, yellow is caution, and red is having a downstream impact. The NFRC project, or the North Fork Rose Creek Diversion Project, objectives and approach is the physical separation of the contact and non-contact water streams, which is provided by a 1.9 kilometer long engineered channel. A non-contact water diversion channel intended to convey non-contact water from the upstream and separate this water from the waste rock dumps impacted seeps. The contact water collection and conveyance system intended to collect water from the waste rock dump impacted seeps and flowing into the NFRC and transport for transportation for temporary storage and later treatment. Alteration of the NFRC required a Fisheries Act authorization, including a fisheries habitat compensation measures. The project proceeded under urgent work, so no other regulatory review was required. The main design objective is for the water quality at the monitoring station NFSW010, which is located at the North Fork of Rose Creek Mine Access Road crossing to meet water quality criteria, or the EQS. This is a picture that shows the original alignment of the North Fork Rose Creek really well, where it follows along, see if my pointer will work, where it follows along the toe of the acid generating waste rock dump. This is looking southeast, southwest, and this is the head pond right before it passes through the waste rock drain. Historically and currently, the North Fork of Rose Creek supports significant populations of Arctic grayling, burbot, slimy sculpin, and round Arctic fish. The NFRC was electrofished prior to the commencement of the realignment project, and fish barriers put at either end so the fish could not pass and re-enter the creek while there was construction. There were challenges maintaining the EQS compliant water quality downstream while completing the construction. So a site-specific water quality management plan, policies, and procedures were developed and followed during the construction. Parsons' environment team monitored the water quality and conducted fish toxicity testing throughout the project to ensure regulatory compliance and ensure the aquatic habitat was protected. Parsons also operated an on-site water quality lab, so analysis could be completed quickly and any water quality issues mitigated immediately. During the construction of the North Fork Rose Creek Diversion, over 5,000 water quality samples were run through the on-site lab. This map shows the key water quality monitoring stations We have in routine water quality sampling in 2013, during the routine water quality sampling program showed elevated zinc concentrations at RCSW 014 or at number 3. This is the last station before the water leaves the mine footprint and heads down valley. As a result of this, in 2013, there was an increased investigative water quality sampling program initiated, and it revealed that there was elevated zinc was found at NFSW 001, number 1, the head pond, and at NFSW 002, immediately below the rock drain. This map gives a bird's eye view of how the water flows through the system. The red star at the top shows where the water comes from the upper Faro watershed. The Faro Creek flows down here, and in the 1970s, there was the Faro Creek Diversion was constructed to divert the water away from flowing over into the Faro pit. It flows down and connects here with the original North Fork, and they join and flow down along, and originally along the base of the waste rock dumps. Pool here at the head pond, and then pass through this haul road or waste rock drain below and flow through the contact water system. Down here, they join the Rose Creek Diversion, take a small turn, and then leave the mine site at RCSW 014. This is another map showing the other routine monitoring stations that surround the investigative monitoring stations, which are highlighted in yellow. And then in green, you have the compliance point NFSW 010. Metal leaching and acid rock drainage, or MLARD. I'm going to talk a little bit about that. The Faro mine was constructed between 1968 and 1998 when historical mine planning practices were utilized, which did not necessarily plan for closure or test for geochemical characteristics of the mined rock, and did not identify appropriate storage of the rock, and so they were sort of mined out and placed beside the pits and in large waste rock dumps. Current mine design plans design plans for closure prior to the construction phase, where non-acid generating rock, the new word NAG for non-ARD rock, and PAG, potentially acid generating rock, is segregated, and PAG rock is stored in lime facilities, protects against MLARD until final closure. Acid rock drainage is produced by the oxidization of sulfide minerals, mainly iron pyrite or iron disulfite. This is a natural chemical reaction which can proceed when minerals are exposed to air and water. Acidic drainage is the result of naturally occurring processes, including weathering, the water cycle, and industrial activities associated with land disturbances. Mining is a big source of ARD because in the mining process, acid-forming minerals are brought to the Earth's surface and exposed to natural weathering processes, whereas normally they would remain deep in the Earth, held in anoxic environments, which are free of oxygen and protected from the atmosphere. These acidic conditions can cause metals in geologic materials to dissolve, which can lead to the impairment of water quality when acidic and metal-laden discharges enter waters used by terrestrial or aquatic organisms. Acidic conditions can liberate various metals at different pH levels. Zinc concentrations at Faro are one of the metals that is increased in the surface and groundwater because of acid rock drainage. This is a slide which shows you the main sources that cause acid rock MLARD, the pathways and which receiving environments are impacted. The sources, you have your tailings, waste rock stockpiles, ore and low grade ore stockpiles, heap leach materials, the pit walls and underground workings, which we do not have underground workings at Faro. Your pathways or runoff, infiltration through mine waste, infiltration through soil or vadose zones, groundwater, surface water, uptake by biota, and movement of mine waters and in the air. The receiving environments are the groundwater, surface water, air, soil, and sediment. At Faro, we do have surface and groundwater plumes that have been impacted by ARD. The impact on aquatic life: when fish are exposed directly to metals and H+ ions through their gills, impaired respiration may result and cause chronic and acute toxicity. Fish are also exposed indirectly to metals through ingestion of contaminated sediments and food items. Iron hydroxides and oxyhydroxides may physically coat the surface of the stream sediments and stream beds, destroying habitat, diminishing availability of clean gravels used for spawning, and reducing fish food items such as benthic and macroinvertebrates. Acid mine drainage, characterized by acidic metalliferous conditions in water, is responsible for physical, chemical, and biological degradation of stream habitat. Water contaminated by acid mine drainage often contains elevated concentrations of metals. This is why both elevated concentrations of metals. And on the right, you can see that the metals can also biomagnify through the food chain. Daphnia, or water fleas, are what we test for at Faro, as well as rainbow trout. They're very sensitive species to all types of environmental pollutants. But as you can see, if the water fleas are ingesting a metal, and then it's the uptake into the small fish, into the larger fish, and up to the higher trophic levels of bears and eagles. This picture is a picture of an environmental monitor taking a water sample at Faro. So the NFRC realignment concept is to keep the clean water clean. The yellow line is the original alignment, and the blue line is the new alignment of the channel. I'm going to actually flip through a few slides here because it's not showing the proper presentation. That's my technical issue today, so bear with me. This is a picture of the NFRC project layout. It's an aerial view looking southwest. You can see here, this is the channel that flows next to the waste rock dump. It pools at the head pond and then passes through this haul road or waste rock dam. This is showing the cuts in the haul road. Eric's going to talk about that in a little more detail next. And this is the waste rock dump here, and in the far distance, the Rose Creek tailings facility. I'm going to talk now a little bit about the water quality. This is a picture of the completed North Fork diversion. As you can see, it's quite different. It's been moved right over. They've cut through the haul road, and the clean water is kept clean and well away from the waste rock dumps. And you can see we have a small contact water channel that still flows. And again, Eric's going to talk a little bit more about that next. So on October 24th, at the beginning of the graph, this is when the North Fork Clean Water Channel was commissioned. You can see that you have your, if you focus on the gray line, again, apologies, something happened with my slides. The gray line, this is at the NFSW 010 at the compliance point. And you can see that we had kind of had stable zinc concentrations. Once the channel was commissioned, we had a spike, which we believe was some sediments washing through. And then you can see over the next month, we had a drastic drop in the zinc concentrations in the channel. This is a picture of the same graph, essentially a little bit different scale, but showing how the adaptive management plan lines and gates are used. So at the bottom, you can see before the channel was commissioned, we had higher zinc and we were working in between the cautionary and the area that you'd start to see issues in the aquatic habitat. Whereas once the North Fork of Rose Creek was commissioned, you saw the zinc levels drop drastically. Actually going to skip through a couple of these graphs and go right to the last slide. So the improvements to the aquatic habitat and fisheries compensation, I'm just going to speak to that on my last slide before I hand it over to Eric. We saw an immediate reduction of zinc when the diversion channel was completed. There was improvements to the aquatic conditions. The fish toxicity testing increased, and we increased the water quality testing, which showed us that the general health of the habitat showed improvements immediately and over time. This is a picture of the fisheries compensation habitat that was constructed for the lost habitat as a part of the fisheries authorization permit. And it's some 3 fish overwintering ponds and a little bit of Canadiana at the end. We have beavers on site. They are actually need to normally be removed because they dam up water bodies and can cause infrastructure issues. However, in this case, they won and their dams created even better fisheries habitat. At that, there's still some challenges ahead, and I'm gonna hand it over to Eric, and he's gonna talk about the construction piece. I'm gonna jump over here.
Yeah, thank you, Karen. So yeah, just to continue on the good presentation that Karen started, part of the actual construction of the new diversion, there was some related work packages that we had to put in place to be able to actually execute that huge heavy civil work at site. First, we had to, and I will not go, there's 20 of them, but I will not go in details on each of them. But on the high level, we had to construct a construction diversion because we needed to keep the water flowing while constructing the new diversion. We needed to construct access roads to be able to haul all the granular material that was required to construct the diversion, because it was not just an excavation, it was a cut and fill, and we were in the negative, so we had to import the good granular material to construct the diversion and the sides of the diversion. Also, we had to construct the inlet and the outlet, so to block the actual original alignment. Also, we had to construct a huge camp at site to be able to house the workers that were coming in town to do that work, because in the little town of Faro, there was not enough accommodation to welcome all the workers. So we had to construct a camp. Also, we had to do some electrical work, because the whole road that you were seeing, well, along that whole road where we did a big cut-in, there was a power line that was feeding the other side of the mine. So we had to do some construction of a new substation to be able to cut and remove that power line. Next slide, please. Thank you. So we had to construct the overwintering ponds as fish habitat compensation. We needed to salvage the fish and construct fish barrier. So all those were work packages that Parson had to tender out to public bidders to have them to do that work. Okay, and we're still, yeah, additional power line work, fish barrier. Okay, so those are the major work packages associated with the actual construction of the North Fork of Rose Creek. Next slide, please. As Karen mentioned, so the idea was to keep the clean water clean and contact water away. The project was not only to move away the diversion because water are migrating and we can still be in contact. So the way it was done, we kept the actual new diversion at a higher elevation, and all that new diversion is lined from one end to the other one. So you'll see in the next couple slides, there's some liner work that was done. So first we had to do from top left to the bottom. So we had to do some excavation work to relocate or to work on the new alignment. And as you see the exposed soil, and we put at the bottom a geotextile and then covered it with granular material to create a subdrain to prevent any potential uplift or groundwater pressure, because we're putting a impermeable geomembrane on over top, so we have to remove any potential pressure buildup. And that work was done like in a sandwich format. So there was like 7 types of granular material that was put in place to construct the sides and the bottom of the new diversion. At the bottom picture, you can see, and I will request the control here because I will need to use my pointer. Okay, so you see my pretty face here in the bubble. So here is the former haul road that was connecting the Faro mine side to the other side of the mine, because what you've seen at the beginning, we were showing mostly the Faro side and the open pit and the tailings pond and the waste rock dumps. But there's 2 other pits that are 13 kilometers away in that direction here. In that direction here, where the mine exploited 2 open pits, again for lead and zinc, and they were hauling the ore along that haul road. But this is no longer in use, so we were able to cut it open, and that material here was used to was repurposed to construct the diversion. So again, in a perspective of sustainability, we were trying to reuse as much as possible of material that we have on site instead of breaking open new undisturbed area to create to remediate the site here. And on the forefront here, you can see the actual contact water that we're still managing, and we can see here the head pond that was well, it's an artificial pond because it's the water that is accumulating upstream of the haul road, and at the bottom of the haul road there's a rock drain, so there's big rocks that is kind of allowing the water to flow through and get on the other side. So during the construction of the new diversion, we had to maintain that that system in place. Next slide, please. Oh, it's not working.
I think you have to advance it, Eric.
Okay, where do I click for this? Oh, I don't know who did that, but that's good. It's working. So as I was saying earlier, so we're constructing the side of the diversion. You can see here the dozer is pushing sand. That will be the bedding material to receive the geomembrane on top of it, because we need to protect the geomembrane and provide a very, very fine material, well, a material that is self-draining and that is fine enough to not create any or generate any punctures through the impermeable barrier. And that material was put in place with dozer, compacted with packers, and you can see a lot of work activities at the bottom here. Next slide. Thank you. So you can see the top picture, the placement of the bituminous membrane. That membrane was welded in place. You can see the propane tanks and the workers who are torching the membrane, and part of that, there was a huge QA/QC program that was testing those welds and seams to make sure that they were done properly. And at the bottom, you can see that geomembrane covered by sand and bedding material that was to receive the riprap. On the last bottom right picture, this is the construction channel where we're kind of maintaining the flow from the Rose Creek diversion away from the new diversion, which is on the left side of that channel here. Next slide. So a aerial view of the work. So on the forefront, this is the construction channel. So that was conveying the water of the North Fork of Rose Creek during construction of the new diversion that we see on the back side here. So we can see some haul rock trucks that was bringing material above a construction bridge to the work area. And you can see here a culvert that is moving or capturing and conveying the water from the upstream side because water is still flowing from here, the runoff. So we had to capture the runoff and to bring this to the construction channel to be able to work and dry. So you can see on the bottom right, the placement of the riprap was completed, while upstream of that culvert, they're still working on the membrane. Next slide, please. So here we see a good picture of the actual cut in the haul road. So that generated a huge amount of clean and material that was reused and repurposed for the construction of the diversion. On the bottom right here, we can see a bit of the actual head pond. So the contact water and the natural flow of North Fork Rose Creek is still flowing here under the remaining of the haul road through the rock drain while we're finishing the work on the new diversion. Next slide. So an aerial view of the diversion once commissioned and open. So you can see the water now is flowing through the new channel, and we can see some step pools along it, along the flow path. We had to create these because the drop in elevation was too high to maintain a non-turbulent flow, so we had to create some steps and also to reduce the energy of the water and also to allow natural fish passage for the graylings to be able to migrate uphill back into the inlet pond. You can see here the orange water, which is the actual remaining contact water overflowing. So now that it's not getting into the clean water, it has to go somewhere. So it's still getting outside or on the surface environment in this location, and to able to mitigate the impact of that water to the natural environment downstream, because it's nice to separate the bow flow, but if you're not doing anything to capture that water here and they're mixing back again here, we did that work for nothing. So to prevent that, there's an interception system that was constructed in this area. Next slide, please. So we can see here, this is the pump house under which there's a sump that is capturing through a drain that is under that that original channel here. So it's capturing the shallow groundwater and part of the superficial water here. So we're pumping that water at about maximum flow, 20 liters per second, and pumping it through that pipeline that we can see here, uphill back to the Faro pit. In addition to that, we have here another set of interception system that were there prior to the new diversion here. And we have another sump interception system in this area that is capturing water and moving it back to the Faro pit to be treated later on in the season. And this system was fully commissioned in May 2021. So it took like 5 months, 6 months after the actual opening of the new diversion to fully commission that system in place. Next slide. As a conclusion regarding the new construction here, so North Fork Rose Creek Diversion Project separated the clean water from the mine impacted water. The zinc level decreased and were below the effluent quality standard at the compliance point, which Karen showed you where it was located. The overall downstream water quality improved immediately. The aquatic fish, aquatic habitat and health improved also. And the fish habitat compensation plan also added improvement to the fish habitat. That's all I had to say, and I think now Jessica and Kristen, it's the time for the questions, if there's any.
Yeah, thank you, Karen. Thank you, Eric. It was a really great presentation. It's amazing the challenges, but also successes for managing so much water to such a massive site like this. So yeah, if there are any questions, you can either enter them in the chat and we'll read them out, or you can raise your hand using the Teams function, and we will unmute you and ask you to ask your question live. So I see we have a question in the chat. What is the implication of permafrost for planning and executing the project?
Well, that's a good question, and I didn't touch the subject here, but within the footprint of the new location of the North Fork Rose Creek, we had to deal with some permafrost because that location is within the bottom of a valley on the side of the mountain that is not exposed a lot to sunshine during summer. So we still have some permafrost in that area. The issue with permafrost is when you're playing with it, especially in summer, you will just introduce heat in a frozen environment, and that soil will kind of melt and liquefy. So you're no longer excavating soil, but you need to manage some kind of sludge, and it's not workable. So we had to plan that work during winter months to be able to excavate solid state soil. It's a bit harder because it's frozen, but it's way much easier to do it that way than doing it in the winter. And as a consequence of that, we had to, and that's the reason why there's a very thick sandwich of different granular material on the side of the new diversion, because we had to recreate some thermal blanket to prevent the remaining permafrost to melt.
Okay, thank you, Eric. We have a next question from Eric Mysona. Why does the environmental assessment process require so much time?
Great question. The environmental assessment process takes quite a long time because it's a very collaborative process. We're required to, or Canada is required to collect a few years of baseline studies for effects monitoring. There's permitting happening in the background, so dealing with different government agencies. There's lots of community collaboration and incorporating different stakeholder interests to make sure you come out with a holistic, comprehensive environmental solution at the end. So it takes a lot of time.
Thanks, Karen. Next question is from Hassan Tavana. Is there any evaluation of groundwater, or it is just surface evaluation?
No, there's been a lot of well testing and a very comprehensive groundwater water testing program at the site. Multiple ground wells all over.
Okay, next question from the chat is from Laurel May. Do you expect the remedy to evolve over the lifetime of the site, and will the sump continue to run?
Well, the sump that we showed here is just the first step of a more comprehensive interception system. Because although we're achieving a lot of interception of the shallow seep and the surface water, there's still some surface water that is flowing depending on the season, and we have to intercept all the drops of water at that point. So and we have to keep in mind that it's a very, very complex environment, and it was very difficult to assess how much water would remain overflowing or seeping through once we completed the construction of the diversion. So as a first step, this was the first interception system, but in the final remediation project, there will be an improved system, and we're actually working on a plan to have a new or improved system put in place in next year. So we're short answer is no, we're not foreseeing an improvement of the water quality in the short term.
Eric. We have another question. This is from Kevin Doust. What was the final ballpark cost of the project?
Just for the construction of the diversion itself, we're about 50 million. If you're adding all the other work packages related to that work, we're more around 80-something million.
I guess that's Canadian dollars, or maybe it's.
Yes, yeah, no, that's Canadian dollar. Yeah, you're good point. So 50 million US total ish.
Okay, if there's any more questions, again, you can raise your hand and we'll call on you, or you can enter it in the chat function. So next month's webinar will be on October 12th at 12:30 Eastern. It will be presented by Akshay Parenki and Ryan Thomas on encompassing the realm of PFAS, production to destruction. We hope you will join us for that webinar. One last call for any more questions today. As I mentioned, this webinar is being recorded, so it will be posted on our YouTube channel in the next few days. If you had anything you wanted to go back and refer to, or anything that you'd missed. Seeing no more questions, I think we'll call that a wrap. Thank you to everybody for attending today. We appreciate your attendance and your questions, and we hope to see you at next month's webinar.